Cape Cod is known for its sandy beaches, but what else could it be known for? Glaciers? The geologic history of Cape Cod mostly involves the advancing and retreat of the last continental ice sheet, which we call the Laurentide ice sheet. Through radiocarbon dating techniques, the geological events that created Cape Cod occurred within the last 25,000 years, while other local formations are millions of years old. The continental glacier covered the Great Lakes and all of New York and New England. Sometime after 23,000 years ago, the Laurentide ice sheet reached its maximum advance, which is marked approximately by Nantucket and Martha's Vineyard. 2 miles thick in some places, Laurentide's weight crushed and pulverized the Earth's surface and picked up the shattered rock of New England and the coast of Maine as it moved south. Large basins in the bedrock surface south of Cape Cod were responsible for the overall shape of Cape Cod and the islands. The relationship between the deposits and lobes can be seen here. Within a few thousand years, the ice sheet started to retreat rapidly, and by 18,000 years ago, it had retreated away from Cape Cod. By roughly 15,000 years ago, the ice had retreated from the Gulf of Maine and all of southern New England. Rock debris deposited by glaciers is called drift. Drift consists of very fine to very coarse rock debris. If unstratified and unsorted, it is called till. Till is a mixture of all sizes of rock debris, ranging from clay-sized particles to very large boulders. Till is deposited directly by ice and is unsorted because ice cannot separate rock fragments of different sizes. Many boulders are still resting where they fell from the ice. Meltwater poured from streams draining the glacier and sorted the stratified gravel and sand. Rock fragments settle quickly and deposit in layers called strata. The smaller clay and silt-sized particles are carried by meltwater streams until they settle out according to the size of their particles. The coarsest first and the finest last. Meltwater stream sediments that are laid down over and around glacial ice are called ice contact deposits. Local ice contact deposits include silt and clay, till, and large to very large boulders. Seen here, most drift on Cape Cod has been fashioned into either moraines or outwash planes. Moraines are ridges of earth formed by moving ice. Most moraines are formed when ice front remains more or less in the same place because the advance of the glacier is balanced by the melting of the ice front. When the debris falls free of the ice, it accumulates along the ice front, much like the material at the end of a conveyor belt. Outwash plains make up most of the Cape Cod landscape. They are made up of sand and gravel deposited by meltwater streams that flowed across the plain in a braided pattern. This resulted in a broad, flat, depositional surface that slopes gently away from the ice. In many areas, this is known as the plains. Due to the lack of topography and the incredible soil quality, the plains of Cape Cod have been used for farming for centuries. More recently, many of these locations have been turned into airfields. Outwash deposits also form a highly irregular and unorganized morphology called kame and kettle terrain. A kame is a knoll or hill composed of outwash deposits which originally filled a hole in the ice. When ice melted away, the deposits collapsed to form a hill. A kettle is just the opposite of a kame. The outwash was deposited around and over an ice block. When the ice block melted away, the outwash collapsed to form a hole. This figure shows the relationship between buried ice and collapse morphology in kettle holes and the ice contact head of outwash. One of the most common examples of glaciation on Cape Cod are the erratically located large to very large boulders. Usually in the moraines or ice contact terrain, these glacial boulders are too large to have been carried by running water and must have been deposited directly by ice. One of the few certain things about the Cape is that it has continued to change ever since the glacier retreated. Cape Cod has been battered by tides and storms which have dramatically eroded the shoreline and over time, the overall shape of Cape Cod. Water always goes where it wants to go, and nothing in the end can stand against it.